Have you ever stopped to think if an AI really sees the world the same way we do? We tend to imagine them as these super intelligent brains, but when it comes to just looking at something, they've been missing a key piece of the puzzle. Well, today, we're going to dive into a totally fascinating new approach that teaches AI to stop just describing what it sees with words and to start actually thinking in pictures.
It's a simple question, right? But the answer is, well, way more complicated than you'd think. We're talking about vision language models, VLMs for short, the AI that powers all that image recognition stuff. And yeah, they're incredibly powerful. But let's check out an example where things go a little bit sideways.
So get this. A state-of-the-art AI was shown a picture of a tennis court and asked a simple question. How many white vertical lines are on the ground? Its answer? 2. Just 2. Which, if you've even glanced at a tennis court, you know is completely, utterly wrong. I mean, it's a counting task a 5-year-old could nail. So why did this super smart AI get it so wrong?
That failure right there points to a fundamental blind spot in how most AIs process visual information. And to really get our heads around it, we need to compare how we see with how they see.
When you look at a scene, you just get it. Your brain instantly takes in the shapes, the depth, the context all at once. We think in pictures. But a typical AI can't do that. It has to take that rich visual world and translate it into a text description for itself. It basically has to write a little paragraph about the picture before it can even begin to figure out what's going on.
And that's the absolute core of the problem. It's a lost in translation moment. When you try to squash a complex, continuous image down into a handful of words, you're going to lose details. It's like trying to describe a beautiful song using only 5 notes. All the nuance just vanishes. The AI missed those extra lines on the tennis court because they just didn't survive that text bottleneck.
So the challenge becomes pretty clear. We've got to help AI skip that messy translation step. And now, researchers have developed an incredible new method to do just that, a way to finally let an AI think directly in pictures.
It's called chain of visual thought, or COVT. Instead of thinking in a chain of words, this framework lets the AI generate an internal chain of visual tokens. You can think of it like the AI is creating a little mental sketch or a blueprint of the image in its head before it even tries to come up with an answer.
So, that's the big idea. But does this new method actually work? Well, let's revisit that tennis court and see what happens when the AI is using chain of visual thought. Okay, this time is different. Before giving an answer, the model doesn't just write a text description. Nope, it generates an internal visual thought. For example, it might create a quick mental map of all the edges and lines in the image. This grounds its reasoning in what it actually sees, not some clumsy summary.
And the result? Bam! The AI correctly answers there are 5 vertical lines in the image. It nails it. By thinking visually first, it could perceive all the details that were previously lost in translation. This is just a perfect illustration of how powerful this new approach is.
This is incredible stuff. But it raises a pretty big question, doesn't it? How do you actually teach an AI to create these internal visual thoughts? I mean, these models are built on language, so how do you get them to start generating these little mental sketches? Well, the researchers developed a really clever 4-step training program to do just that.
So how do you get an AI to learn this new skill?
It all breaks down into 4 key stages. First up is comprehension, where they basically teach the model the ABCs of these visual tokens. Then comes generation, where it's guided to start creating these tokens on its own. After that, in the reasoning stage, it learns to actually use those visual thoughts to answer questions. And finally, you get to efficient reasoning, where it learns to be smart and only generate the specific visual thought it needs for a particular task. So what are these visual thoughts actually made of? Well, the model learns to generate a whole toolkit of different types. You've got segmentation tokens, which are for understanding the shape and position of objects. There are depth tokens, which let it understand 3D space, what's close and what's far away. It uses edge tokens to pick out all those fine-grained details, like the lines on that tennis court. And then there are these things called dino tokens, which help it get the deeper, more abstract meaning of a scene.
Okay, so this all sounds amazing in theory. But the real question is, does it actually perform better? The proof is in the pudding, so let's look at the data.
On a key industry benchmark called CV Bench, the standard text-only model scored 74.5. The model with chain of visual thought, it scored an 80. Now that 5.5-point jump might not sound like a lot, but in the world of AI benchmarks, that is a very significant improvement. It shows this makes a real, measurable difference.
And in some areas, the improvement is just staggering. On tasks that specifically require understanding 3D depth perception, like figuring out which object is closer, the COVT model saw a massive 16.4% performance boost. This is where thinking visually really pays off.
So we've seen what this is, and we've seen that it works. But let's zoom out for a second. Why is teaching an AI to think in pictures such a huge deal for the future?
To really see how big a step forward this is, just look at this comparison. While some other approaches have a few of these strengths, COVT is the only one that checks all the boxes. It reasons visually, it uses all the rich information from the image, it understands 3D space, and, this is crucial, it does it all by itself, without needing external tools. It's a truly self-contained visual thinker.
So, what this all comes down to is that chain of visual thought isn't just a clever trick to get higher scores on a test. This is a fundamental shift. It's about giving AI a much more robust, reliable, and grounded understanding of our world. Its perception is based on what it actually sees, which makes it more intuitive and, in a way, much more human.
And that leaves us with one last kind of mind-blowing question. We've just taught an AI to see the world in a way that's a little more like us, with its own internal visual thoughts. But as this technology gets better and better, you have to wonder, what new kinds of perception will it unlock? What will an AI that truly thinks in pictures be able to see that we've been missing all along?